Hello and welcome back. In this video, we'll be looking at the next homework assignment on differentiability and tangent lines. So first one, I'll start out with tangent lines. These are fairly straightforward. When we look at a straight line, we can talk about its slope, and if we pick a point, we can talk about the slope at that point, and the slope here. We can see from the equation is just going to be 1/2. So the slope along this line, so at every point along this line, is going to be equal to 1/2. Over here, when we're looking at a curved line, if we want to pick a point and we look at the slope there, well, the slope will change at different points. So if we look at the slope here versus the slope over here. Over here, you can see that we're kind of come down. Over here, we're going up. So the slope is changing at different places. But when we know the slope, I can sort of draw this nice straight line, and this line will hit that point at exactly one point, and this is what we'll call a tangent line. And I'll go into this in more detail in a little bit. But first of all, I want to quickly remind ourselves, how do I find the slope at a particular point? So let's say that I want to find the slope right there, so I can come up with the equation of this, of what I'm calling this tangent line. So the derivative of a function is this guy right here. And this is how we find the slope of a line that we can't just read off from the equation. So like over here, x squared minus 2. If I wanted to find the slope of this line, I have to use this equation. This part is called the difference quotient. And this is essentially the equation for the slope of the line, because we have f of x plus h and f of x are going to be the heights of the functions in two different places, and then if I take x plus h minus x, that's going to be the x value in two different places, so we have rise over run. This is the slope of the line, and we want it to be as close to just the same point as possible. So we want to take the derivative, take the limit as h approaches 0. This is going to give us the equation for the slope of the line at any point. So let's go through this example here. So we've got f of x is equal to x squared minus 2. So let's find the difference quotient first. So I need to take f of x plus h minus f of x all over h. And we'll simplify this. So we'll have x squared minus 2. I need to plug in x plus h into there. So this is going to be x plus h squared minus 2. And then we're going to subtract f of x. So we're going to subtract x squared minus 2 all over h. And let's continue this on the next line. I'm going to simplify this a lot. So x plus h quantity squared, that's going to be x squared plus 2 x times h plus h squared. So that's this simplified. Then I have the minus 2. Then we have minus x squared minus 2. So that's going to be plus 2 all over h. And then from here, we can see some things cancel out. I have an x squared and a minus x squared. I have a minus 2 and a plus 2. And then I have an h on the bottom, which will cancel with a factor of h from each one of these guys. So what I'm left with is just going to be 2x plus h. So this is what I want to take the limit as h goes to 0 of 2x plus h. And here, when I look at this, h is approaching 0. X isn't changing at all. So 2x isn't changing. so 2x is just going to stay 2x. H is approaching 0, so this gets to go away. So our limit is just going to be 2x, and this is what our derivative is going to be. So let's come back up here. So we found that our derivative is going to be 2x. So right here, we're at x is equal to 1. So if I want to know the slope at exactly x is equal to 1, I can just plug that in. So at 1, my slope is just going to be 2 times 1, which is 2. So the slope of this line that touches my curve exactly once is going to be 2. So this line here has slope exactly equal to 2, and I know a point that it passes through, so I could write down the equation of that line. So let's look at tangent lines in a little bit more detail as well. So a tangent line touches the curve at one point with the same slope as that point. So for example, we normally talk about tangent lines on circles. So for instance, if I chose this point right here, I could talk about the tangent line being the line, if I could draw straight, being a line that does this. It touches exactly at that point, and it has the same slope as that point. I could draw something. I could draw lines that don't touch at exactly, or sorry, that don't touch with exactly the same slope. So for instance, here we can see that the slope is kind of going up. But if I were to draw the line like this, this top one is not tangent to the circle, and this guy is tangent. So we can kind of see the difference between something crossing through a line or passing right by and touching it exactly once. Now, I want to be a little bit careful here, because a curve can do all sorts of crazy things. So if I picked a point, say like right here, and we could imagine that the slope is kind of doing this thing, if I continue this line, it eventually does cross again right there. And you know what? That's okay. This is still a tangent line, because at this point right there, we are passing by with the exact same slope. So it doesn't matter what the curve does elsewhere. Over here it came back down and came up and crossed our line again. That's okay. A tangent line just has to touch at one point with the same slope. That one point is right there. So for instance, we could have lots of tangent lines here. I could have a tangent line right there that will be passing up there. I could have a tangent line right here, which might be going almost exactly flat. So we have all sorts of tangent lines on a curve. So we could find, for instance, tangent lines at various points. So let's do that here. I have my equation f of x is equal to 1 over x squared, and I want to find the tangent line at x is equal to 1 and at x is equal to negative 2. So to find the equation of a line, I need the slope of the line, and I need a point that it passes through. Well, the point that it passes through is pretty easy. X is equal to 1, x is equal to negative 2. I can figure out what point those pass through. I just need the slope. So let's find the slope by finding the derivative. So first of all, we need to find the difference quotient, which is going to be f of x plus h minus f of x over h. So if I plug in x plus h into here, I'll get 1 over x plus h squared minus 1 over x squared all over h. And here I've got some fractions on the top. I want to simplify these. So in order to consolidate these fractions, I am going to need them to be over the same common denominator. So what I'll do is I will multiply the one on the left by x squared. So I'll get x squared times x plus h squared all over x squared. And then the one on the left, I'll multiply by x plus h squared. So I've got an x plus h squared, and all this is still divided by h. So let's simplify this. Well, the two top fractions I can now combine. So this is going to be x squared minus x plus h squared all over x squared times x plus h squared. But if I'm dividing a fraction by h, I just get to put this on the bottom. So I consolidated the tops, which is everything but the h, and then if I divide by h, I'm putting an h on the bottom of the fraction. So let's simplify this some more. So now I'm just going to focus on the top. So I've got x squared minus, and I'm going to be subtracting x squared plus 2xh plus h squared all over h x squared x plus h squared. Simplifying some more. If I'm subtracting all these guys, the x squared minus the x squared, that'll go away. But on the top of the fraction, I now have minus 2xh plus h squared over h x squared. Oops, this should be a minus, shouldn't it? Just about made a mistake because I'm subtracting everything in there. And then x plus h squared. And now we'll see a couple of things cancel out, and it'll be a lot easier. Oh, I'm running out of space. I'm writing too big. So this h, I'm dividing everything by h, so I'm dividing everything on top by h. So what do I have now? If I pull out the negative sign, I've got minus h, let's see here, 2x plus h. And here, I can now take the limit as h goes to 0. So this is going to be our difference quotient, and if I take the limit as h goes to 0 of this guy, this is going to be maybe I didn't need to pull out that minus sign. I'll just leave it like it was over here. 2x minus h over x squared times x plus h squared. What I can do is I can just take the limit of the top and I can take the limit of the bottom. So if I take the limit of the top as h goes to 0, well, h is just going to go away. So I'm going to get I'm just going to get minus 2x on top. On the bottom, as h goes to 0, well, h is just going to go to 0, and nothing much is changing. So I have x squared times x plus h squared. Well, x plus h, this is just getting closer and closer to x. So this is getting closer and closer to x squared times x squared, which is going to be x to the 4th power. And dividing a copy of x on top and bottom is going to give us minus 2 over x cubed. This is our derivative. I will continue this example in the next video.